Hi, folks. Thanks, Marco. I was super excited when I saw that Marco's organised his conference. Ever so slightly jealous, actually. But really, really excited to see this happen. I think it's been brilliant. I think Marco's and the team have done a really, really good job. I'm going to talk about logging. I normally do the talks which are a bit more about people and teams and stuff like this. That's what we do where I work. A lot of combination of technology and teams, but today I'm going to talk a lot about logging. It's fairly technical. I've spiced it up a little bit with some photographs and some other things, which you'll see in a second. My contention is this: the way we use logging is often broken, and I want to share some ideas about how we can make logging more awesome and why we should care. In a nutshell, a lot of software that we're building is moving from monolithic designs into more lightweight components, whatever you want to call it. The bigger picture is Internet of Things, where we're not just talking about VMs or containers, we're talking about a huge expansion in the number of things that are sending data into a central location. There's also some pirates in this talk, so watch out for them in a bit. So as Marcus said, my name is Matthew Skelton. There's my Twitter handle. When I'm not diagnosing build systems, CI, deployment pipelines, someone's monitoring a metrics installation or whatever, I'm writing some books. So writing one for O'Reilly, which will be published soon, and one with some people from Redgate, database tools vendor, about continuous delivery and stuff. Does anyone know what this is? Hands up. If anyone knows what this thing is here. Any guesses? Some kind of loom. That's correct. That's correct. So it's actually with the first programmable device. It was built around about 1890. This actually sits in an old mill close to my house in the north of England, where we used to produce a lot of cloth. This still works. This is over, what's that? What does it make it? 120 odd years old, and it's still programmed with these punch cards here. This is the kind of stuff that I get excited by, right? So you see where this is going. I've been tweeting on operability for a number of years. You'll find me, again, on operability on Twitter. And, of course, there's a kind of obligatory website, whoownsmyoperability.com. Have a look at that later on. There's basically some links to further blog post materials, books, and this kind of thing. What I need to do, actually, is put the source code on GitHub so I can take pull requests for additional resources. So I haven't done that yet. I will do that at some point. So I'm a big fan of logging. Not quite as big a fan as this guy from Monty Python, but fairly close. So what's logging for? Well, lots of things. Exceptional situations is one of them. Edge cases, metrics, analytics, audits. There's a guy called Evan Phoenix. We'll see him later on. This is his list. My view is that it's really logging should be used as an execution trace. And we'll see what that means as we go through the talk. There's lots of ways in which I think logging is unloved or broken. I'm not going to read these out, but you'll see these later through the talk. When you see a yellow slide, that's stuff which is bad. When you see a white slide or a blue slide, that's stuff which is good. So there's some stuff which is good, and we'll look at what that is as we go through the talk. Why do we care about this stuff? We need to reduce the time to detect problems. That's a really important thing as we get more and more devices coming together, as the cost of downtime increases. But also, I'm interested in increasing team engagement with the systems that we're building. Need to increase certain kinds of collaboration and our ability to configure things. So these are the four things that sit behind my take on logging. A little bit of background about me to explain where I'm coming from with what I'm going to share with you. Way back in a long time ago, mist of time, for my final year project at university, I built an autonomous weather station that was designed to survive lightning strikes, because it was long story anyway. So we built this thing, and there's, what is that, Internet Explorer 3 or something like that? That was the homepage for the website that I built. That thing had to log, because it was in the middle of a golf course in Saudi Arabia, and if there's a lightning strike, that's obviously by definition disconnected. Then it had to reconnect later. To be able to understand what was going on, we had to come up with some logging that was useful. I then wrote some software for MRI brain imaging scanners Obviously, if you've got someone who's sitting inside one of those machines, you don't really want something to go wrong. If something does go wrong, you really want to understand what happened, because you might get sued by the hospital or by the person themselves. So wrote some brain imaging software. Logging was absolutely essential in that context, and of course still is for things like medical devices and healthcare. I did some stuff with oil well monitoring. It turns out so our sensor was at the very bottom of the oil well. It turns out it's cheaper to drill a new oil well than to take a broken sensor out of the oil well and replace it. And it's not cheap to drill an oil well. So those are the constraints under which we were working there. My software was actually running on the surface, but the way in which we designed the instrument gauge meant that it had to be enough resilience. We had to have lots of logging in there. So there's a whole load of log. This is the software that I built. A whole load of logging coming through from the device, or from each half of the device, to enable us to see what was going on. Then I did some web scale systems stuff for financial companies. Interesting stuff here. When a plane is refueling, it's not actually just taking on fuel. What we're also doing is taking off data and putting new data on. So the systems that we were involved with were the in-flight entertainment systems, where we were pulling off all of the passenger usage data as you're clicking around on a little TV screen. We're scraping all that stuff off, sending it off to the advertising agencies so they can sell you more stuff later. But you didn't know that. But that's what we were doing. So we only had 20 minutes to do it. Because that's how much time you get for a plane to refuel. So you have to make sure that stuff works. Then did some stuff with healthcare. So as I mentioned, we have to understand what's going on there. People's lives can be at risk, or at least their health can be at risk. More recently, I worked at a company called the Trainline.com. So they're the UK's busiest travel booking website. Lots and lots of transactions. People need to, if someone buys a ticket online, they head to the train station, they expect to be able to pick the tickets up, otherwise they might not get home that evening or might not be able to make their business travel trip. We have to be able to understand, if something does go wrong, be able to trace through and resolve the problem semi-manually, otherwise they get very irate. And then more recently we've been doing some work with some legal firms, some online payments, and I've just done a charity race with Just Giving, who are a big online charity donations company. We're also working with a company, very cool company, who are doing some. They're disrupting their previous startup, which had disrupted the industry at the time. Anyway, it's quite cool stuff they're doing, video processing and stuff, and we'll come back to them later on because it's relevant. The long and short is logging makes things work. That's where I'm coming from. Logging is often the first thing that I will put into a new piece of software. Forget any kind of minimum viable whatever, I'll plug in the logging first. For those of you who are thinking some other thoughts in the back of your mind, the stuff I'll share now helps to lay the ground, if you like, for things like event sourcing, structured logging, CQRS. I'm not going to explain what they are, but if you're aware of what they are, you'll see how this kind of fits in with that. It's not supposed to be an alternative. It's supposed to simply kind of lay the ground and open the door to some, let's say, more advanced or proven ways of building software systems. So how is logging usually broken? I'd say it's unloved or broken because it's discontinuous. Actually, yeah. There's sometimes we're logging only errors. Sometimes the logging is bolted on. Often companies are not aggregating and searching logs. And we often have fallen into this trap of having to specify the severity when we write the code rather than later on. I'll explain all this stuff in a minute. So we're talking about the old way of logging. I was on holiday in Scotland recently, and I saw this sign. This is not photoshopped. This is a real sign in a footpath in Scotland. So I was very happy to see that. And you'll see some more holiday pictures in a minute. So using logging mainly for errors, I think is broken. There are software tools out there which, I think they call them error trackers or exception trackers. I think this is the wrong way of looking at it. This is the wrong way of looking at what logging is for. I think we should log everything. I'll explain what I mean by everything in a minute. Many organizations use logging inconsistently, and so the logs end up sort of decaying. We can't really trust what's going on. We don't really have a sense of the same kind of information in different logs from different places. Some people think that logging slows down software. Now, there might be some special cases where if you're in the middle of some tight calculation loop, you don't want to log every single execution of that loop, fine. But if you think about the larger picture of software, the bigger picture is we need to be able to diagnose it quickly when there's something going wrong. We need to be able to recover from errors. We need to understand, perhaps restore a transaction, something like this. So the pure execution speed of a single kind of thread of execution from one request is not the only thing we need to optimize for. We need to think about other things as well, including recoverability and so on. So I don't really think that logging slows down software when you look at the big picture. I've literally had a conversation with people who say, well, I don't want to put any of that logging stuff in because it pollutes my domain model as a software developer, or these kind of things. I think that's just crazy. But there it is. Some people think that software is about, I don't know, constructing an abstract model of some sort of business concept rather than actually producing working systems. I very much have the opinion that the software we build is about building working systems. And some people think that logging is just for those, weirdo ops guys or ops people, which I think also is wrong. In many places, people assume that logging is basically free. It's easy, right? We've got the logging system. We just use log4j, log4net, whatever we're using, and we don't need any budget. Why do you budget for logs? Should be just there for free. That feels like a failure to me. We need to allocate the right amount of time, effort, budget for logging. So treating logging as a first-class thing. We're nearly at the end of the bad stuff. I'm going to get onto the good stuff in a minute. If logging only happens in production, or logs are not available to developers, that also feels like a real anti-pattern to me, a really bad thing. That can happen for lots of reasons. Perhaps your logging tool is so expensive that you can only afford it in production, in which case perhaps have a look at another tool. And fighting over what severity level to use for different log entries also feels like a waste of time. I'll talk through some techniques for getting around that one in a minute. A lack of time synchronization between machines is quite a pragmatic thing. Seems quite obvious. But if you're bringing together logs from lots of different parts of the estate, and the servers are not in sync in terms of their clock time, that's really not going to help you try and work out what's going on. All right, let's have a little. I'm just heading off to the side now, just for a little story. So this is where the pirates are. My great-great-great-great-grandfather was this guy, Edward Boxer. He was an admiral in the British Navy. He was a bit of a thug, I think, or something, because this is what the newspapers at the time drew him as, a bit of a bulldog. But what he did do was become very interested in the quality of the records that ships kept. He ended up founding some sort of a naval observatory in Canada. And so I tried to find some of the ship's logs from the ships that he was on. I couldn't find any, but I did find some from the time. And the kind of things they recorded were these: weather, the course of the ship, sightings, latitude, longitude, basically where they were. Crucially, they recorded these things in the ship's logs even when things were quiet. They recorded these things every day. Now, it took some time to get to the point where there was a standard for what was logged on ship's logs. But by the time he was serving around the middle of 1850, or slightly earlier, it was fairly standardized. Now, I'm not making excuses for the British Empire or anything like that, but I'm pretty sure that it would have been much more difficult to sustain a worldwide kind of empire like that that was based on shipping, that was very naval-oriented, without an excellent understanding of where these ships were. And that was down to the logs being very high quality. Another important thing, of course, was accurate timekeeping. And there's a guy called John Harrison who came up with a way to solve that, basically, so people could calculate longitude. We'll come back to him later. Why did the Navy, the merchant Navy and the military Navy, why did they log? There's lots of reasons for verification, traceability, and accountability all relates to the people who are paying for the ships. So people who are backing it, the insurers, this kind of thing. They wanted to know if there was an incident, if the ship was lost or partially lost or some cargo was lost, they wanted some traceability for what was happening, what had happened. So that's part of the reason. Also, we were exploring. They were using logging to explore, work out where they were, find new coastlines, this kind of thing, which had not been seen before. And as you'll see later, we can actually use these kind of things to drive how we use logging as well. So we're providing verification, traceability, accountability for the people who need it, particularly in financial services, but increasingly across lots of sectors, but also using it to explore the way in which our software actually works in production. Right, if modern software used logging, sorry, other way around, I'm getting this wrong. If the Navy in the 1800s wrote its logs in the same way that a lot of us use logging today, then rather than nice detailed logs that look like this, then I think the logs at the time would have looked a lot more like this. Just pirates, sharks, bigger sharks. So the date format is all different, right? There's no consistency across that. There's no useful information there. That doesn't look like a ship's log. So how can we make logging awesome? There's lots of these ways. We'll go through each one now. So the example here is from this company that we're working with at the moment, who are doing large volume, or increasingly large volume, basically real-time video processing for delivery to some major global corporations. I can't say any more than that right now. This is what their schematic of the kind of software infrastructure looks like. Don't worry about the detail. The crucial thing is stuff comes in at the left-hand side. It goes through various different stages and gets processed. So there's lots of different stages at which the video is in as it's getting processed. So one of the things that we're doing is to use event IDs. If you think about a piece of software or system that you're familiar with, how many different states does that software get into? It's a deliberately vague question, but just anyone care to throw some ideas out? How many different states does your software have? 2 states, running, not running, right? But how many more than that? So there's lots of unknown states that our software can get into. We've never seen before, different exceptions, different kind of timeouts, who knows what. Fine, so there's a load of unknown events. But there's a lot of events that we know about, or states that we know about. We can represent all the unknown events by just a single identifier, in effect. So we've got a bound on the different ways that we can represent how our software's working. So we can represent these distinct states. If the language we're using has got something like an enum, we could use an enumeration for this. It doesn't really matter what we use, but enum's kind of useful because it gives us unique values, it's sparse values. We can enumerate the details. So can you see that at the back? Can you see that? So we've got some technical events like the application started. We've got a domain event here, which is basket item removed. So we can capture stuff which is business domain specific, but also technical things. It's human readable. So if we see that in a log, we know exactly what it means. We can also, if we group things by string, we end up being able to search for everything related to baskets super easily. We'll see that later on. And because in this case we're using enumerations, it's easy to work out that these have got unique values. Now, this is useful for one system. If we've got multiple systems, we may want to have unique identifiers globally across all those systems, if you like. That might be okay, or it might be difficult to manage, in which case each individual system can have its own set of IDs. It doesn't really matter. The crucial thing is this is an enabler for the team that is working on this system. It helps them to understand what's going on. So we don't all need to be kind of, we can be all individuals if we want, that's all fine. So we've in this case, we've scoped it to the order service, and then that value has become unique again. So here's a context with what we saw before, switching from kind of monolithic designs to smaller components interacting. We don't really have a single view using a debugger anymore. When we had monolithic software, we could drop it all into the debugger. That's all fine with lots of different components. It's a bit more tricky. We can use a remote debugger, but it's kind of boring. I certainly find it kind of dull to be attaching a remote debugger all the time. So going back to the system here, the green arrows there represent two distinct events or states. We've uploaded something. There's some sort of worker job here. So that's, we do some activity, and then it's finished. So it's at least two states. There's worker job started, worker job finished, okay? And we just go through the whole system. Go through the whole system. There's lots of different discrete states of execution. Each one of these is a kind of a state transition. Even within this box in the middle, we can probably break that down, and there's some additional processing inside. The level of detail we go to is entirely dependent on what's useful for the team. That's the crucial thing. It's a team enablement thing. So we're not talking about instrumentation of every single method call beginning and end. That's not what we're talking about. We're talking about what's useful for the team to know and describe that as a particular state. Another technique we can use is to use unique-ish identifiers for each request. When I say request, that's like an HTTP request or client-server request or something generated off a queue. And it's tagged and passed through downstream layers. So it needs to be unique-ish because within a particular time window, it only needs to be unique within that window. So let's say within the last half an hour, within the last day, depends on what you're likely to search for. It doesn't need to be unique across all time. But once we assign the ID, then it flows through, and as we move it into a new queue or into a new processing thing, that identifier gets traced through. That means we can see where bottlenecks are. In this particular system, the work we were doing with them was to identify exactly where the bottlenecks were in this system, because they didn't know. All they knew is how long it took ends to end. But it was impossible for them to tell, with all these different moving parts, which part to optimize, which part to go and fix. So that's why we plugged this stuff in. Some people, I'm sure in the room now, are thinking, what about APM, Application Performance Management? It's a very good question. Because APM gives us useful insight, that's fine. And it can be a really good tool, but there's a danger by using APM that we see it as just something we sort of paint on in production, in the live environment. We don't take the chance to learn and internalize how the software is actually working. So a few of these techniques like this, like I'm showing today, are useful for the team that's looking after them, building the software systems, to understand much more clearly how the system actually works. So it's worth doing a few of these things manually, rather than leaning entirely on something like APM, to allow us to trace execution, the execution flow through the system. It helps us to understand much better what's really going on with the software. And there's a small overhead, but my contention is it's absolutely worth paying for that overhead because we get a much better understanding. Who can raise their hand and say with absolute certainty they've always got the log level, the log severity level right when they've released the software? So I'm talking this about debug, info, warning, error, critical, this kind of stuff. And we're using a lot of logging libraries. We actually have to specify this stuff when we write our log line, which to me has always seemed really weird. So I think we should not have to fix this at compile or build time. So this is how it normally works. Don't worry about the details. The little red arrow thing here means we've got to specify it right at the top. We can abstract away, log4j or whatever, but we still have to. It bleeds through up. It kind of bleeds upwards to where we have to make the logging call. So instead, if we can have some sort of mapping of if you remember, we use these event IDs which describe specific states. If we map these through to a severity, then when we do the logging call, we don't need to specify the severity because we've got this stuff in a config file or in a database. That makes our logging code, so here's like some sort of JSON representation of that, whatever. We need to be able to tune the logging levels using config. And it makes our logging statements in the code itself much cleaner, much cleaner. We're describing what's happening, not some sort of technical, we're removing some of the technical detail from the point at which we log. So use something like enumerations or something like that which allows us to kind of describe the different states in our application. Technical and domain events, that's totally fine. You give them different ID, different kind of integer ranges or whatever's appropriate. Need to accept that with distributed systems, debuggers are less useful. So we need to be looking at different kind of tools, different ways of approaching how to understand what's happening with software. And we can trace calls all the way through the system. We absolutely need to have log aggregation and search as a first-class thing. Version control is now a first-class thing, right? There's no one who, hopefully here, who doesn't use version control. Continuous integration tools should be first-class thing. So likewise, log aggregation and search should be first-class. Here's a nice whiteboard diagram that I drew. So there's some agents in red that are squirting the logs into a collector, and then we have a nice little web interface that we can use to search logs. It doesn't matter which one you use. Just use one. Pick one and use it. Probably, if you're smallish, you'll start with a software as a service hosted online thing. And then as you scale, you'll probably end up moving to like on-premise, self-managed, probably Logstash-based thing. But it doesn't matter. Just use it if you're not using it already. Lots of nice charts and graphs that you get out of them. That's all great. And crucially, we can search, because we've set up our event ID strings correctly, I can find all of the events that relate to database just by searching here. I mean, it's not rocket science, but it's massively empowering. We need to develop the software with log aggregation right from the beginning, because that's a piece of our system now. So from the very beginning, software developers are plugging that stuff in and using the log aggregation tools to help them build the software. It may mean, if you're at a certain scale, that you actually need to have additional data pipes from your production environment, because you might get to the point where you're pushing so much stuff that you might need to add an additional NIC, like a management NIC or something, rather so you're not contending with the main traffic coming in from the outside. That's also fine. We need to be able to test our logging as well. We can't assume it's going to work. It's just another system component. Testing logging gets easier in this case because I know that at the point where I've clicked on add item to basket, I should have entered basket item added into the logs, which means I can just grep for that item. I mean, it's relatively straightforward stuff, right? It's not hard to do this, but it does require that we've had some discipline about how we're describing what's happening in the system. Logging is just another system component. Don't forget something like NTP. This is our time sync. This is our longitude measurement. If you remember from the maritime analogy, you have to have time synchronization, otherwise this stuff doesn't really work very well. Crucially, it's a dev and ops collaboration tool. This is the Wikipedia DevOps collaboration image. I guarantee these guys are collaborating using Logstash or some log aggregation thing. You can't quite see it. It's a bit. They've also got Cake down here at the bottom of the screen. That's been cut off, unfortunately. The combination of log aggregation and Cake is definitely the best kind of DevOps collaboration. So where's it being used? With a really great team a few years ago, we built a second-tier system for London Stock Exchange. So not their main trading platform, but a regulatory reporting system. So it's in there, and that's still running as far as I'm aware. Some stuff for healthcare. As I mentioned, we're plugging this stuff in for these guys doing video processing. It helps with, we're expanding this usage into some other areas as well, which start to be possible, or we can use this stuff for things like auditing compliance. I use that with a small a and a small c. It helps with these things. It's not the only solution we need, but it starts to help with thinking about how we prove certain things are happening. We start to move to a kind of preemptive fault diagnosis thing rather than reactive, and so on. So yeah, there's lots of ways in which logging is sort of unloved, or I think broken. I think we need to move to this kind of continuous event ID stream, aggregating, tracing, using logging, pushing out metrics. Need to think about designing our systems with logging from the very beginning, rather than it's something that we bolt on afterwards. And we don't need to think about severity as when we're developing. We can have that configurable later on. When I ran this talk, the pre-production version of this talk was a few weeks ago, right? And someone said, there's no thought behind aspect-oriented. Has anyone done aspect-oriented programming? No? Okay, maybe this is where we kind of decorate the source code with various things, including logging. And she said, there's no thought behind aspect-oriented programming. So there are techniques that look a little bit like this, which including one of them is aspect-oriented, but I'm hesitant to use the word mindful. Where's the guy who's doing mindful before? I hesitate to use mindful logging. The crucial thing is this stuff is not mindless logging. So we're moving away from logging mindlessly into a position where we're using logging. We're thinking about it. We're using it to help us reason about the systems we're building and operating. What else? There is a thing called structured logging. ThoughtWorks, in their ThoughtWorks radar from May 2015, recommend to adopt structured logging. A lot of the techniques we've seen here today are very similar to what's in structured logging. It just doesn't have a fancy name. We're basically talking about moving to a position of sanity when we're dealing with our software systems. If you're doing anything to do with IoT, it's going to become increasingly important to kind of adopt some of this kind of stuff. And that's pretty much all I've got. There's a really great talk by this guy, Evan Phoenix. The link's in the slides, you can't quite see it here, where he's talking about some similar stuff here. So if you're interested in this stuff, go and search out Evan Phoenix. And at some point, there'll be a book called Software Operability that I'm busy writing. The MVP for that, the smaller version is a little book on operational features that we're doing first, and then hopefully by the end of this year or early next year, there'll be a book on software operability that'll be out. And that's it. Any questions? Yep.
Have you looked at Zipkin? Or
looked at?
Zipkin?
Have I looked at Zipkin? Yeah, we've not looked at that specifically, but I'm aware of it. Yes, it's from Twitter or LinkedIn or someone, isn't it? Yeah. Yeah. No.
I was just curious as to how you'd see logging being from the search and trace in the way that you're mentioning it.
So we've not used Zipkin, but it does look very cool. The stuff I wanted to emphasize here partly is that you can get a lot of benefit from doing some fairly simple things without plugging in kind of lots of other tools and things. So the learning aspect of some of these techniques is a huge part of the value. But yeah, if there's tools like Zipkin that will work and give the same benefit, then that's totally fine, I suppose. Yep.
Logging over UDP or TCP?
Log.
That is better to send a message and forget, or be sure that it's written.
So the question is, should you push the data via TCP or UDP?
Yeah, basically, it should persist or not.
I would expect to do it over TCP because you'd absolutely want to get the stuff there, which is partly why you might have to look at the network architecture and things to give you a bit more bandwidth, or to make sure that that's one thing I meant to put in, actually, I forgot. I generally want to push the logs onto disk, local disk first, whatever that means, because that gives me a buffer. If the network is partitioned, even just temporarily for a couple of seconds, it can log to disk, and then the agent that's sitting on that VM or container, or whatever, can then pick up from disk. It acts as a semi-persistent buffer first. Obviously, you limit the size of storage on disk, but it's useful to have that. Sorry, did that answer the question?
Yeah.
Anything else?
You mentioned sort of like using use of log information in sort of audit or compliance situations. Have you done anything around sort of non-repudiation or like secure signing of logs, making sure they've not been modified after they've been created.
So the question was, have we done anything about non-repudiation secure signing of logs after they've been created? Very good question. Short answer is no. Are you going to talk about it in a bit or not? No.
I'd like someone to come with a good answer.
Yeah. So it's hard. So that's why I emphasised that it was kind of audit with a small a, because if you want proper full audit with the really scary auditors, then they want you to prove that log couldn't have been tampered with. So this stuff is kind of more for like the internal audit, just general more awareness of what's happening. It is an important point, and I don't have an easy answer to that, but it's stuff we're thinking about, how to really get to the point where no one could have changed that data in that log. That is absolutely believable. But yeah. Sorry. Yep.
So you mentioned using correlation IDs to be able to track log events through a stream of process.
Yep.
Some processes will split into multiple batches and then rejoin subsequently, or go off in various times.
Mm-hmm.
Do you have any suggestions on how to track through these sorts of processes?
It depends on what the short answer is. It depends on what's useful for the team. So if you've got a simple split, it could retain that ID and perhaps drop a new one on as well, so that then you end up with multiple IDs being passed around. That could be useful. If something goes onto an asynchronous queue, you'd want to somehow keep that ID, keep the original request ID perhaps before it got dropped onto the queue, then probably spin up a new ID in addition. It depends on the nature of. So I suppose the simple one is, don't just limit it to a single ID if that feels false, if that doesn't feel natural. So have the flexibility to add as many correlation IDs, I guess, as feel useful for the team. Thank you.
Thank you.
Thanks.